Okay, our next speaker is Craig Struve. Had a chance to visit with him over supper last night, and I'll guarantee you this is going to be interesting.
Oh, gosh.
Welcome.
Well, good morning. How's that sound? I, listening to Jared and Dan, there's one thing about farming. There's one thing about production and agriculture. Farming is the most complicated production system in the world. I often compare what we do as farmers to a John Deere manufacturing tractors. And if there's a tractor coming down the line and a mistake is made, they pull that tractor off, fix the problem, and keep right on going. And the next tractor doesn't have that problem. But everything you guys do, or the farmers in this room, is obviously you get one chance. And so the complexity is just mind-boggling. So let's see, advance. There we go. So my name is Craig Struve. I'm with a company called SoilView. And the topic we're going to talk about this morning is soil sample results and what you should expect. Little side note on SoilView. It's a company that we purchased in 2010. It was formerly called Midwest Independent Soil Samplers. It was owned by Tom McGraw, who many of you people know. We're a service provider to agronomic service providers. So any company, any organization, be it crop consultants, retail agronomy centers, seed companies, anybody that has agronomy support, we will pull soil samples for them, as well as other site-specific things. We do crop scouting on a limited basis, mostly for crop emergence and population. We also install a lot of moisture sensors in the irrigated countries, especially in Nebraska, Kansas, and Oklahoma and Texas. We operate the central Midwest. We have samplers that cover parts of 16 states. We start in western Ohio and go west to eastern Colorado and north and south. The dots on the map represent different things. The red dots represent our system of area managers, which we're fortunate enough to have two of them with us today. Sitting right over there, Katrina, and Ryan Broggett. And Ryan's from Mason City, Iowa, covers into Iowa and up into southeast Minnesota. Katrina lives at Cato, Minnesota, and covers our northern market in Minnesota. So any questions I can't answer, or any questions you direct, let's direct it to those two. We have 4 main facilities that we operate out of. In your right-hand corner is our facility at Hutchinson, Minnesota. This is where all of our orders come into. They're dispatched out to the area manager in the particular area to be sampled, and he will then dispatch them to samplers. Your lower left is our facility in Story City, Iowa, and a similar facility at Wood River, Nebraska, which is west of Grand Island, Nebraska. And these are facilities that we store, maintain, and deploy equipment out of. And upper left is our office in Polina, Iowa, which is about 50 miles south of Worthington, Minnesota. And that's our HR and accounting office. I also represent in Iowa a group called Iowa NREC, which I think is very, very similar to the Minnesota Agricultural Water Resource Center. And NREC is made up of commodity groups, much like your organization is, Farm Bureau, corn, pork, Poultry, Beef, and the Agribusiness Association of Iowa, and which is what I represent on the NREC board. So, soil sample results have always been important, but today, I truly believe, and I think you would agree with me, they're more important than ever. Production costs, environmental impacts of applied nutrients, and even technology advancements that we have today to better apply nutrients, take advantage of applied nutrients, even yield monitors, which have been around a long, long time. I think they're terribly underutilized, but that's another technological advancement that can help us a lot. We also believe that soil sampling and soil analysis can be improved, and that's what we want to talk about a little bit today. So what should you expect from soil sample results? Well, I believe you should expect consistent results from sample cycle to sample cycle, while accounting for nutrient removal or application. I think you should be able to take your sample results, put them on a spreadsheet, look at them over a period of years, and if there's large differences, I truly believe there's something wrong. And I think it's our responsibility as a sampling company and soil labs, which we do not analyze soils, but we know that soil labs are also working to do better. These are just examples of some fields where we got 3 sample cycles, and I know this farm. Oh boy, that's complicated.
All you gotta do your finger here, then it'll go down.
All right.
Okay.
If you look at potassium, I know this particular field is a no-till, strip-till field. And the desire was to see what it took to raise potassium levels over time. And with the purpose of trying to increase soybean yields. And so he was successful in raising potash numbers. And also he's been successful so far in increasing soybean yield. So, but I think we should be able to take our soil analysis, like I say, put them on a spreadsheet and look at differences over time. 1 year does not certainly doesn't develop a pattern. So what causes these soil sample results to vary? Well, it's the sampling process. Now, there's other things too, but what we're going to talk about today is the sampling process and also the lab process. In the sampling process, there's probably 4 things that are mainly can cause differences. One is sampling depth. If we take on a new account, in many cases, we're going to get a phone call, aren't we, Ryan, when the results come back? Because I just about guarantee our results are going to be different. And they're probably not going to be as high. And most of the time that's caused by sampling depth, which in comparing analysis, we can normally prove. Or it can also be, something within the lab. So we're going to talk about these 4 things here in the next few minutes. And here's a project we did for a research company in Iowa on, we did this for 2 reasons. One was their membership was concerned about no-till corn and soybeans and nutrient stratification. And they were also, I don't need to go into too much detail here, but they also wanted to compare nitrate recovery in cover crops and non-cover crops. So these fields, there were 6 of them in Iowa. They were probably within 100 miles of Ames, Iowa. And these fields had strips of cover crop, no cover crop, cover crop. We went in with a Giddings probe, which is a hydraulic probe that's designed to take deep soil samples in large cores. This one was, I believe we use a 2 7/8 inch probe and opening, and we come out with a nice 3-inch core of soil. We went down to 24 inches, and we divided it up into these increments, and of course it was sent to a lab. They were a little bit concerned and some of them surprised at the amount of stratification in these soils, and concerned that it was probably going to cause them to lose yields. So as a comparison, should have circled that for you, but looking at now these are high soil test levels really in this particular field. The second field, the 102 sample, a little bit lower, but still very, very stratified. So when you look at this, you think, oh my gosh, we're going to have a crop influence here. So we went to a corn-on-corn field within this same circle of these 6 fields. And I'm familiar with this field. It's heavily tilled. And when I say heavily tilled, you mentioned DMI tilled, Jared, and it is DMI tilled. But look at the stratification there as well. Again, high fertility, but quite stratified when it comes to phosphorus, potassium. Sample number 2, these are variable soils in the same field, but if you're taking shallow samples, a 4-inch sample instead of a 6-inch sample, you're going to likely influence the results of that test. So we've got to be careful with depth. Sample intensity. And our samples in Minnesota, we 89% of the samples that we take in Minnesota are 2.5 acre grids. You can see the breakdown. We do some other grid size samples, but it's primarily 2.5 acre grids. We do some zones, not a lot, and a few composites, which amount to about 5% of the samples that we take in Minnesota. We think there's a definite advantage to grid sampling. Before we get to that, let's look at the results. These are our spread of nutrients in Minnesota, and phosphorus on your left ranges from 9 to 40 or above 40, and potassium, there's quite a variance as well. And it should be noted, remember, these are grid samples, and most of them are 2.5 acre grid. So the variability here is not field to field, it's within fields. So there's quite a bit of variability. How we sample, can really pick up this variability, and you can then determine how you're going to manage it. Here's a study. It's a 97 acre field, 1.1 acre grids through whole field composites. So the 1.1 acre field, there'd be 83 samples in that field. And we'll take phosphorus as an example. Okay, I'm sorry. The phosphorus as an example ranges from 8 to 124 in that 97 acres. If we drop down we'll go down to the whole field composite, which is not a very good way to sample, I don't feel, but we have a phosphorus level of 28. So if we're going to apply phosphate to that field based on a composite, we're going to over-apply a lot of areas, but we're certainly going to be under-applying a lot of areas. And you can see the different levels of information that you can get out of those soils. Here's a field that we did in Nebraska. This quarter was purchased, and the gentleman allowed us to go in and sample in different increments, 1.1 composites, as well as 6 zones in the field. And I'm not going to show you all the different plant food levels, but this is a map of the tonnage needed if we raise the fertility levels of that soil to the University of Nebraska levels all in 1 year, which wouldn't be done, but this is the tons it would take to do that. So we'll take a quick look here at pH, which if you're on acidic soils, and normally most of the fields that are farmed, they'll have high pH soils certainly, but they'll also have a lot of soil acidity, especially when we get away from this western side of Minnesota. But the amount of lime that would be applied on a 1.1 acre grid, for example, was 280 ton. So the more intensive you sample, the more variability you're going to pick up. And in this case, the more lime you're going to apply. But if we split the field also into 2 comps, so each field represented approximately 70 acres. One comp, one half the field required 181 ton of lime, the other half 218, for a total of 399 ton of lime. So we definitely are going to be over applying lime in many areas of that field based on a comp. Phosphorus, similar. The comp again would have had us applying the highest rate of phosphorus on that field at 16.86 tons as compared to a 2.5 acre grid of 12.98 tons. So you can start to recover sampling costs quite quickly when you manage nutrients on a smaller basis. Field conditions. This, we're starting to get ahead of this, we think. And Katrina deals with this probably as much as any of our area managers. You wouldn't think of sampling a field like this, would you? I hope not anymore. We just about refuse to sample this. There's 3 things that are wrong with it. It's very hard on the sampler, very hard on the equipment, and the results are terrible. You cannot get good soil cores in fields that have been worked. And this is an extreme, but even a shallow working of a field, a disking, a field cultivator, if you disrupt that top 3 to 4 inches, and to get a good core of soil is next to impossible. So what you end up doing is getting poor soil cores or going deep enough to get a full core. And both of them are wrong, and we're going to give you the wrong information. I apologize for this slide. I couldn't get it into something you could see that was larger. Quite a few years ago now, this is not a new slide, but I was in Concordia, Kansas, and an agronomist called me from Iowa. And he said, Greg, we got a problem. There's something wrong with the sampling of this field. And I was putting gas in at this gas station. Every time I drive by it, I think of Larry. He's the agronomist. And I said, well, Larry, what's the matter? Well, the results are terrible. I don't know what you guys did. Well, I said, let me find out a little bit. So I called the office in Hutch. They looked up the order. This was in early spring, probably February. And we had sampled it in the fall. So they look up the order, and our samplers oftentimes will put notes on their order and about the field. And there's various things, livestock, gates were locked, field was half harvested, whatever. So we can go back and see. This sampler put on there that he called his area manager that the field was horribly rough. It was or worked, and very, very dry. And it was just really impossible to sample. The area manager called Larry, and Larry said, I got to have it sampled. I think what happened, Larry forgot to turn it in, right? And the farmer worked the field. So anyway, we went ahead and sampled it. And so in the fall, after it was worked, that top right-hand picture, the average phosphorus was 10 parts per million. We went back, third picture down, and the average phosphorus was, can't even read it myself, 39. And the farmer said, which is, he's quoted on the bottom, that this is much more representative of the field, as Larry said too. So what happened? The only firm ground in the dryness, the only firm ground that our sampler could get a core was in the bottom of that chisel trench. So it was way too deep. It was just unfertilized soil. And so we have used this example in a lot of cases. Potash also, just to, if you can't read that number, the second slide up from the bottom, the potassium in the fall was 89. And after leveling it, and I'll also talk about it, I'll talk about it a little bit later, we sampled it early in crop. And we'll talk about that later, but the potassium went back up to 205. So it's just amazing how you can get different results with different conditions. So this brings me to our one of the ways we do a lot of, or one of the times a year we do a lot of soil sampling, and that's what we call EIC, or early in crop. And depending on our account, they'll let us sample from the time that field is planted and until they're too tall to traverse with four-wheelers. So if it's a cornfield, we'll sample those first, and then we'll sample beans. We can sample beans later, oftentimes into July, the first part of July. You know, I used to be in retail, and we always took our samples in the fall after we got everything else done. And it was just common practice. So sampling in the fall, there's no good reason to do it, except that's when we always did it. So it's a habit more than a good agronomic practice. And especially in Minnesota, I mean, you guys up here have got a tillage tool in the field with a combine, and it's really hard to catch up with those combines. So 12-row combine or an 8-row combine we can't keep up with you. So so we really like to switch sampling to what we call early in crop. It gives you as a producer much more time to review those results, talk to your agronomist or consultant about what you're going to apply that fall. If you use your yield maps as your crop removal, which you should, that goes into a layer in your planning process, so you can reapply nutrients that have been removed in those areas. Quality cores and the number of quality cores. This is university data. There's a picture of a sampler in crop sampling, and we do all of our, I should mention too, we do all of our nutrient sampling with hand probes. That sampler, when they pull that core out of the ground, they can see that core. They know the quality of it. If it's not of good quality, they can discard it and not put it in their hopper. So university data, this is every university practically has information on this, the number of cores it takes to get a quality sample. We take 10 to 12 quality cores, and we use a probe that's, in most cases, we use a probe that's 0.56 inches in diameter opening, It's called the consultant's probe or an agronomist probe. And so we take 10 to 12 quality cores. Now, they may take 15, they may take 18. But if that core isn't of high quality, it gets discarded and they take another one. We also use, SoilView uses an expanded center point system to sample. We found this to be very effective and a repeatable way to sample, even though we're moving in that field. So the sampler drives to a center point. This isn't two samplers, this is one sampler, and we expanded the picture. So that sampler drives to the center point. His tablet says that he's on the point, and it turns green so he can sample around that four-wheeler at that point. He moves ahead 20 to 30 feet and repeats that process. And really an effective way to avoid nutrient spikes in an area and get a high quality core. The work, I should mention, the work on this was actually done in the University of Minnesota way back in the 90s, I believe. And it's a very good read, and we're very happy with the results. If you ever require or requested a tracking map of our samplers in the field, which every field is tracked, when that sampler is out there, it's recording his time, his location, and his pattern in the field. So if you ever question how we sampled, how long we were at each sample point, we can produce this tracking map for you. And this tracking map shows you see there's two white dots at every grid center point, and that's when that sampler moves ahead to take those second 5 to 6 cores of soil. These tracking maps come in very handy in training, and the grower ever questions how we sampled, we can show them this. Last night at dinner, we talked about TFI. TFI stands for the Fertilizer Institute. And a few years ago now, they came with the 4R campaign, which I'm sure many of you are familiar with. And the 4Rs are the right source, the right place, the right time, and the right amount, the right rate. And it's really a good, effective marketing of nutrient application. But we expanded it, and so far the TFI hasn't complained to us. But we think there should be 5 Rs, and the first one being the right sample, because we feel it's impossible to do a good job of the 4 Rs that follow it without the right sample. I'm going to speak a little bit on Iowa NREC. As I mentioned before, I'm on the board of this organization, and we have some similar missions as you do up here, and but three of our missions, one of them is measuring and demonstrating environmental progress and fostering innovation and development of new environmental technologies. And of course, the third one is equally as important, and that's education to assist Iowa farmers in achieving environmental goals. When our nutrient strategy was originally developed, there was 34 scientists from the Midwest, including scientists from Minnesota. Some of you probably in this room participated in this. They developed this nutrient reduction strategy on both nitrogen and phosphorus. And in the phosphorus reduction strategy, we thought there should have been the application of variable rate phosphorus to help in the management of phosphorus. The scientist said they thought it was such a widely accepted practice that it wouldn't do any good to include it because everyone was already doing it. And that, in fact, isn't true. I mean, it sounds like a great practice. And Jared, not to talk about 5 minutes. Ooh. Jared, not talk about the Red River Valley, because I understand what you're dealing with up there, but so much of our areas are extremely variable in phosphate, and variable rate application can be effective. So Antonio Melorino said they would relook at this variable rate application and include it the next time they updated the strategy. Well, NREC decided that they should look at ways to improve variable rate application of phosphorus. And we want to improve producer awareness, rebrand the importance of soil analysis and the confidence in soil sampling and analysis, reach the unsampled acre, and also provide public awareness of what we're doing to manage P, much like you're doing here in Minnesota. So NRAC contacted the soil labs that were doing a lot of analysis in Iowa. And we started out with 7 labs, and since then 2 of them have been sold, or one of them closed down, the other one was sold. So we have 5 labs participating in what's called the Enhanced Quality Assurance Program. Now, all labs are certified by someone. Sometimes they're certified by 2 or 3 different organizations. This isn't a certification program. It's enhancing the quality of these labs where they mutually talk about results and determine how they can do better and get more consistent results. As you may imagine, these 5 labs that are participating now, it's always the best that want to do better. You know, these aren't average. These labs are doing an excellent job anyway, but they're very, very excited about participating in an enhancement program. The oversight of this is through an organization called ALTA, which is a lab certification program. And I'll give you a quick little example of what I think good soil sampling and lab analysis can do. We had a customer request that we sample a small field. It was 18 samples and pull 3 samples from every grid location. So that pattern that I showed you before, that expanded center point, of course, we used that, and so each of those, every time we stopped to take a sample, we would take 3 cores, and so we'd take 30 cores per sample acre. It was a 2.5 acre grid. What the customer was comparing was a hydraulic computer controlled sampler, and he wanted to compare the results. So we went out and sampled. The sample conditions were good. You can't always probe the soil with 3 cores in that tight of area without totally disrupting the soil, but soil conditions were good. This was in northwest Iowa, probably about 20 miles south of Laverne, Minnesota. And so they were sent off to the lab. Now the blue line is the hydraulic probe, and here's the phosphorus. Again, the blue line, if you can't see in the back, is the hydraulic probe, and the other samples are R3 samples. So ours are very, very close. There's potassium. Now, the thing, don't look at all the data, only the red box. This order came to our area manager late in the afternoon. He wanted to get the field done that day. So there was only 18 samples. Normally doesn't take long, but really there was 54 samples because 3 samples for grid point. So he took another sampler with him. So we had 2 samplers sampling this field. And I think it just shows the consistency of what can be done from a depth standpoint when you're sampling. So one sampler took the even number of sample points, and the other one took the odd number. And but the results are incredibly similar. I bet I'm out of time. All right. So with that, I'm going to thank you. And if there's any questions, I'd be happy to try to answer them. And one more slide. Yes. So the question is, do you get concerned with recent fall fertilizer or manure applications skewing your sampling results when sampling cornfields early in crop? We do, and we've got to be careful of this. There's a number of things we need to be careful of. There's more and more strip till. We strip till on our farm. I'm going to answer the question, but we have to be careful of strip till applications, especially if that strip till machine is putting down any type of nutrients. This can be a problem, and it's something we talk to the agronomist about, and they'll direct us when that field should be sampled. Oftentimes, the manure or fertilizer is being put on bean stubble for next year's corn crop. So we're not sampling that cornfield that next summer. We're sampling the bean stubble beside it that has most of the time not received fertilizer. Now, if they're on if they're fertilizing every acre every year, I know we're sampling fields like that, and we're not seeing we're just not seeing the big difference. Once that field is worked and you get all the mineralization during the winter, we just aren't seeing the spikes in fertilizer. But most of the time, the fertilizer is going on last year's bean stubble, if that makes sense. Is it practical that broadcast application equipment can properly apply rates as determined by 2.5 acre grids? Yes, but is it absolutely perfect? No, but it's better than a broadcast application based on other sampling methods. Now, I think there's a couple of things you want to be aware of, and that's how it's being applied and how fast those machines are going. I don't know about the new technology of spreaders, but I am troubled by the speed at which some of these machines run. I know they're going 20 to 25 miles an hour, and I don't know if that machine can react that fast. So, in fact, I don't think they can, especially at high rates. So we instruct our applicators. We get an as-applied map, and which you should get. And there's many things that map will tell you besides what's actually being applied and where. It'll give you the speed of the applicator and how much time he took in that field to apply. So those things have to, you got to watch this because these people got to cover acres, they think, and we want them covered right. Okay, where the hydraulic probe P&K test result in higher because of poor depth control, perhaps too shallow of a sample, or what else could it be? If we had time to look at those samples and compare, I think it was the depth control of hydraulic probe wasn't quite as spot on as they thought it was. So you know, and we can see from the stratification test and that it doesn't have to be too much shallower or too much deeper to affect the nutrients of that. So I think it was just a lack of good control on that hydraulic probe. Do you see a future in which human soil samplers can be replaced with an automated form that maintains quality? I'm sure it will happen. And I especially, at my age, would love to see a mechanical sampler that I could run. I don't sample anymore, and but we've tried. In fact, Tom McGraw, when he sold the company to us, that's what he went into. He spent many, many hours and a significant amount of money trying to develop an automatic hydraulic soil sampler that pulled behind a pickup. The concept was wonderful. He was so disappointed that the cost was well over 100,000. In fact, the last estimate on it was about 150,000. And you know, it's kind of like the story I tell about the mousetrap. I think the mousetrap was first patented in 1889. You can look it up. Since then, there's been over 4,000 patents on mousetraps. And this is the old wooden mousetrap. A little shinier today than it was back then. But so there's been over 4,000 patented since the late 1800s. The biggest selling mousetrap today, guess what it is? It's the old wooden mousetrap. Because the goal is to catch mice. You know, you don't care if somebody can get them with a hammer, just get rid of the mouse. Same with soil sampling. You want the results, you want good results, you want repeatable results. And any way we can do that for you is what our goal is. So yeah, I hope we do get a hydraulic sampler. We've tried them, and they're inconsistent. So okay,